on with Chapter 5, which again focuses on solutions to systems. Systems is a term where you have two equations, tend to have two unknowns, but in high school in Algebra 2 and multivariable, you will get multiple variables with multiple axes. And so right now we're dealing with linear equations, so where two lines intersect, where they share solutions is what we're doing. In 5.1 we learned how to graph to find that intersection. Here we're going to use elimination through substitution. The reason why we can't find a solution at the moment is because we have two variables. So we see in this first equation that when we isolate our variable, we don't have a numeric value for it. It's in terms of the other variable and the constant. So we'd never get a single number or a location, because our location is going to be x comma y. So we never find out what y is. So we can't isolate. That's not the technique. We could graph, but as we've seen, graphing is not very accurate, and we may have to guess and check around that location on a grid line. So what can we do? Well, we can use substitution. We do like the fact that y is isolated by itself. So we have y in terms of x. So in the other equation, where we see the variable y, we can substitute its equal value. So where we see y, we can instead substitute 3x minus 10. So why would we do that? What are the benefits of that? So let's rewrite this equation, 5x plus 2. Instead of writing y, we're going to write its equivalency. It's a balanced equation, so it means the same thing as y. We're not changing anything, we're just substituting a different look, much like when we have p equals 5 and we plug in 5 for the variable p, it's its equal value. So tell me, why is that beneficial? Well, it's beneficial because in both of the equations above, we have two different variables. And here in this new equation, we've written an equivalent equation to 5x plus 2y equals negative 9. We only have one variable. And once we have one variable, we can simplify. We're going to distribute that 2 into both of the terms. So that gives us 5x plus 2 times 3x is 6x, and 2 times negative 10 is negative 20 equals negative 9. Let's simplify. Always simplify before moving variables and stuff. So let's move this equation down. We get 11x minus 20. Let's move the constants now. We get 11x equals 11 divided by 11 divided by 11. X equals 1. So we have part of the solution to the system. So how do I find my y value? Well, what does this represent? This represents the true. It represents the intersecting point. It's going to be a solution to both of these equations. Okay, so that means if I plug it into either one, it would produce my y value, because it's going to produce the same solution, hence why it's the intersecting. So I'm going to choose this equation because I'm looking for y, so it doesn't matter. I could have used either one. And I'm going to plug it back into there, and y equals 3x minus 10. Y equals 3. My x value is 1 minus 10. Y equals 3 minus 10. Y equals negative 7. So I know my solution is 1, negative 7. That would be the solution to the system. That's the point that both of those equations share, that have the same, that they share, that they both have that as a solution. We understand that there are an infinite number of solutions for this equation. And there are an infinite number of solutions for this equation. Do they share any of the similar solutions? Yes, they share this solution. So that's a nice way using substitution. So when we look at these equations, we need to notice, hey, is one of my variables isolated? And if it is, let's take it and substitute it back into the other equation, which is a technique in order to go from 2 variables to 1 variable. So we're going to take that top equation, -3. Instead of writing x, we're going to write what x is equal to in terms of y. And then we rewrite the rest of the top equation. We're going to distribute. -3 times -4y is 12y. -3 times 5 is -15 minus 5y equals 13. We're going to combine like terms. They're on the same side of the equal sign. They have like variables to the same exponent. That gives me 7y minus 15 equals 13. We're going to add 15 to both sides. We get 7y equals 28. Divide by 7, y equals 4. I have my y. I'm going to take the other equation. X equals, because I'm looking for my x value. So this is the most, this is set up to find out what x is. -4. My y value was 4 plus 5. X equals -16 plus 5. X equals -11. So my solution, writing in x comma y, would be -11, 4. We always have to remember coordinates are written x comma y. Now this is a good one. This book does a very good job. I've never seen this before in this example, this type, but you want to isolate the variable and you go, oh, well, 7x, so I'm going to divide by 7. But if we recognize that we have 7 x's are equivalent to a y and a +1, in my other equation, it has that. It has 7x. It wants to know what 7x is equivalent to. So I don't have to necessarily isolate it to have a coefficient of 1. We can actually, if we notice, if it's conducive to it, like it is in this example, we don't have to isolate that top equation. We know. We actually want to know how many 7x's is equal in terms of y's. So being aware of that, that is the attention to detail, as we say. So instead of 7x, we're going to write y plus 1 minus 3y equals -11. We have like terms, so -2y plus 1 equals -11 minus 1. -2y equals -12. Divide by -2, and we get y equals 6. We go back. Now, this isn't as beneficial because it's not isolated, but we can still use 7x. Equals, y is equal to 6 plus 1, 7x equals 7. Now we have to move where the other one we just simplified because it was isolated for x. So once we simplify that right side, we know what our x value is. We just have a step before, but still super easy. My point of intersection is going to be 1, 6. We have y in terms of x's. We're going to take that and we're going to substitute it in for my y value, just the y, where here we substituted for the entire side. So here we're just substituting it for its equal value. Since we isolated for y, we're only going to plug it in for y. So that top equation now becomes 2x plus 2 times what y is equivalent to. Y is equivalent to 12 minus 3x equals 4. 2x, we're going to distribute. 2 times 12 is 24. 2 times -3x is -6x equals 4. Like terms, -4x plus 24 equals 4 minus 24. we get negative 4x equals negative 20. Divide by negative 4, x equals 5. Let's go up. We're going to take that equation, y equals 12 minus 3 times 5. I think it's positive 5. And we get y equals 12 minus 15. Y is equivalent to negative 3. So that point is 5 comma negative 3. And you should be getting these this fast. Okay? Now, none of them are isolated. And we don't have an x plus 7 in any of those. So we are going to have to isolate one of these equations. Which variable in which equation is going to be the easiest to isolate? Well, no. What happened? My smartboard is dying? Oh my goodness. Okay. Ooh, that was weird. A little lag there. So, which is the easiest? I'm going to say, oh no. What is going on? Ooh. Wow. This has never done this before. All right, we're going to do something very interesting in mid-video. I don't know if this is going to, I wonder it'll be interesting to see what you see. Oh, you should probably still see there. I've unplugged the power to the smart board. So we're seeing what's happening here. We may even have to close down the smart board, but I'm pretty sure I'm still recording. So thank you for your patience. Sorry about that. Yeah, you should still be working. And I probably shouldn't have, probably should have closed down the smart board. I'm going to save this real quick. I'm going to save this. I'm going to quit that, and then I'm going to reopen it because I kind of think that it has something to do with that. That's working again. That's working again. Let's open up. Yes. Okay. Let's go to my problem. Thank you. Oof, we're only on problem number. Oh, did it not even save that? Oh, it didn't. Okay. Oh, because I didn't write. Okay. We're back. Thanks for your patience. So I'm going to isolate for this variable. That's going to be the easiest one to isolate over the other variables in the other equation. So let's minus 7, and we get x equals negative 3. Now there's something nice about that. We already have the x value because there was only one variable in that. So we already know the x part of the solution. Now we'll take this top equation, negative 2 times negative 3 plus 9y equals 15. That's going to be 6 plus 9y equals 15 minus 6. 9y equals 9, divide by 9, and we get y equals 1. So I have my solution, negative 3, positive 1. All right, thanks for your patience there. Sorry about that. So again, neither are isolated. So we have to choose a variable from one of the equations. Well, again, I see it's probably going to be easiest to isolate this x in that equation. So if I have x minus y equals 4, all I have to do is add y to both sides, and we get x equals y plus 4. So where I see an x variable in the other equation, I'm going to substitute that. So where I see x, I'm going to plug in y plus 4. So let's rewrite that equation. 2, instead of writing x, we're going to write y plus 4 minus 3y equals 3. We're going to distribute. 2 times y is 2y. 2 times 4 is 8. Minus 3y equals 3. We're going to combine like terms because they're on the same side. Negative y plus 8 equals 3 minus 8. Negative y equals negative 5. Multiply both sides by negative 1. Y equals 5. So that's my y value. Go back to here. X equals my y value, which is 5 plus 4, x equals 9. So I have the coordinate 9, comma 5 as my solution for number 6. Number 7, this time I'm going to isolate the y. You should be getting easier and better at figuring out which equation are you going to manipulate in order to substitute. And it says, hey, solve it by substituting. It doesn't say solve it by graphing, so you shouldn't be graphing any of these. We should be using this technique. So we get y equals negative 3x minus 7. So in this equation, I'm going to substitute for y a negative 3x minus 7 for x. 3 times negative 3x is negative 9x. 3 times negative 7 is negative 21. Like terms, negative 5x minus 21 equals negative 1. Add 21. Negative 5x equals 20. Divide by negative 5. X equals negative 4. Then we come down here. Y equals negative 3 times negative 4 minus 7. Y equals 12 minus 7. Y equals 5. So my solution is negative 4, 5. Do enough of these. This is the reason why we do the extra practice, so we can be proficient. Now, this one's a little bit harder because it's just not doing one step in order to isolate. So we only needed one step in order to isolate our variable y. We only needed to do one step in order to isolate the x. Here, we're going to have to do multiple steps, which is fine. Again, I'm going to stick with the x variable, and I'm going to isolate it in the top equation. We have 2x minus 4y equals 28. I'm solving for x, so I'm first going to move the 4y over. 2x equals 4y plus 28. And then I'm going to divide by 2. And what I do to one side, I have to do to everything on the other. So now I've isolated for x in terms of y's, and now I can take that and plug it back into that other equation. So instead of writing 5x, I write 5 times what x is equal to, which is 2y plus 14 plus 6y equals negative 10. And we like that because now we only have one variable, the variable y. 10y plus, what's that, 70 plus 6y equals negative 10. 16y plus 70 equals negative 10. Minus 70 minus 70. 16y equals negative 80. Divide by 16. Y equals negative, I don't think it's 5. Did I multiply 5 times 14? 25, 6, 7. That's right. 80 divided by 16. I don't think that goes in evenly. 80 divided by 16. Oh, 5. How did I know that was 5? That's kind of silly. I should know that. But I didn't, so I checked. Now we have my y value. Let's use my x equation that I isolated and plug that in. X equals negative 10 plus 14. X equals 4. So my solution is 4 comma negative 5. Make sure you put your x's in your x location, your y's in your y location in your coordinate. Place where most students make their mistakes. We're going to isolate for y. That's just going to be the easiest. We could have done either equation. It doesn't matter which one we isolate for. You will get the same answer. Just you tend to choose the one that involves the least amount of work in order to isolate it. It is isolated in that term. So we go back to the other equation, and that's my y. Ooh, I like this. 6x minus my y. So this is positive y, so I don't write minus x plus 7. This is minus my y value. So my y value is multiple terms, so I have to use Chewbacca. Yep, I know, buddy. I hear you. -1 times x is -x. -1 times 7 is -7. That gives me 5x minus 7 equals -7. Add 7. 5x equals 0. Divide by 5. X equals 0. Y equals 0 plus 7. Y equals 7. And my solution is 0, 7. For number 9. Number 9. A humane society has 73 dogs and cats to be adopted. D plus C equals 73. The number of cats is 10 more than twice the number of dogs. All right, well, I can write that. The number of cats is 10 more than twice the number of dogs. Is 10 more. So cats is equivalent to 10 more than twice the number of dogs. So twice dogs plus 10 should equal the number of cats. I think that's right. Those should be the two equations. We'll check it, throw something down, start working towards a solution, solve it, and then check. Does it work? Do the cats plus the dogs equal 73? Does the number of cats equal double the dogs plus 10? Yeah, let's see. Let's do it. Check it out. Do it. D plus 2D plus 10 equals 73. 3D plus 10 equals 73 minus 73 minus 10. 3D equals 63. Divide by 3. Dogs equals 21. I can go back to my, cats is going to equal 2 times 21 plus 10. Notice cats equal twice the number of dogs plus 10. 42 plus 10. C equals 52. I have 52 cats, 21 dogs. If I add them together, does it equal 73? Yes. Are there more cats? 10 more than twice the number of dogs. Yeah, there are more cats than dogs, which makes sense. There should be 52 cats and 21 dogs. 52 cats, 21 dogs. A wedding planner purchases both small and large lanterns for a wedding reception. The planner purchased a total of 40 lanterns. So we already know small plus large should equal 40. That doesn't equal 180. So the price of the small, so I'm going to multiply the cost per small times the number of smalls plus $40 per large times the number of large lanterns I bought should equal the total cost. So now I'm dealing with cost. This is the total cost for all the small lanterns. This is the total cost for all the large lanterns. If I add those two total costs, I should get the overall cost. So let's isolate S. S equals 40 minus L. And now we're going to plug it back in. So 25, instead of writing S, we're going to write 40 minus L plus 40L equals 1180. Let's distribute. 25 times 4, is that 1,000? I think that's 1,000. 25 times 4 is 100 plus the 0 makes it 1,000 minus 25L plus 40L equals 1180. Simplify before you move. That's 1,000 plus 15L equals 1180 minus the 1,000 gives me 15L equals 180. Divide by 15, divide by 15, and we get L equals 180 divided by 15 gives me something in change. Oh, $12. So each, oh, that's not dollars, Mr. Mac. Remember, S and L are the number. That's important. So I bought 12 large lanterns. I bought 12 large lanterns, and how many small lanterns? Well, small equals 40 minus 12, so S equals 28. So I bought 28 and 28 small lanterns for a total of $1,180. Let's see if that is correct. 28 small, 12 large. Let's go! Find the values. All right, so we have to understand, what do we know? So they tell us one equation, find the values of x and y. So we have one. Can we write another? Because we need two equations in order to make a system. So what do we know about this? Well, if you remember in geometry, angles of the side is going to equal, these are parallel. Well, actually, we're making the assumption that they are parallel. That's not good. They should have this little indicator. That would be nice. They're making the assumption that we know it's a parallelogram, which it is. So we know. It is Monday, so I forgot the bells are going to ring, and they're about to ring a lot because we're going into recess at 10:25. So we know that the sum of x plus y is going to equal 180. Yeah, so this angle plus this angle are always going to equal 180 in all parallelograms. So now that we have two equations, we can isolate one of them for a variable. Let's not use that. Let's use this for yellow and this for green. What am I going to solve? I'm going to solve the other one. I'm going to solve this. I'm going to solve this one, and I'm going to add y to both sides. And we get y, 2x equals y. And I'm going to plug that into this equation. So x plus 2x equals 180, 3x equals 180, divide by 3, and x equals 60 degrees. That's one of the angles, and then we can go in here and find out what my y is. Y is going to be twice that degree. That's 120 equals y. Does x plus y equal 180? Yes, it does. And it's interesting, they don't even put it in degrees. So yeah, my x coordinate, my x angle is going to be 60 degrees. My y angle is going to be 120 degrees. Same thing, we're going to utilize the assumption that these are parallelograms and that they are equal. So we can write a statement that x plus y plus 3 is going to equal 180. We can take this is already solved for y in terms of x. So we can plug that in for my y value. And we would write the new equation, x plus 3, x plus 29 plus 3 equals 180. So 4x plus 32 equals 180 minus 32. 4x equals 148. Divide by 4, and we get 37. X equals 37 degrees. Is that correct? Yeah. And now let's take the y equation, because we still have to solve for y. 29. Y equals 3 times 37 plus 29. Y equals 21, 111? That's 21, 9, 10, 11, yep, plus 29. So y equals 140 degrees. So I have, no, that didn't work. 21, 9, 10, 11. Where did I make a mistake? Where did I make? Oh, so I made the assumption. That's good. See, I thought x plus y equals 180, but it's not x plus y equals 180. It's x plus y plus 3. So if y, this angle is not 140, this angle is actually 143, and this angle is 37, and yes, those two equal 180. So, but y, it wants to know what y is 140. So that's a little tricky. Write them systems of equations in which 2, -1 is a solution of equation 1, but not a solution of equation 2. And 5 is a solution of the system. Then solve the system by substituting to verify that 5. Oh, okay. All right. Write a system of linear equation. Well, where 5 is a solution. So we can say 2x plus 3y, where we substitute 5 and 5 in. So that's 10 plus 15, which equals 25. So that's going to have to equal 25. So that is one equation that is going to solve this. That's equation number 2, solves that. Now I need one that's going to solve this and this. Okay, so we can find the slope. I'm going to use a little bit of chapter 4 here. So using these 2 points, let's write an equation. Yeah, this is how you do it. So 5 minus -1 over 5 minus 2, y's over x's. That's 6 over 3, which has a slope of 2. So we get y equals 2x plus b. And I want it to go through that point. So I'm going to make sure that I use that point. 5 equals 2 times 5 plus b. 5 equals 10 plus b. Minus 10 minus 10, -5 equals b. So I have the equation y equals 2x minus 5 is my other equation, but not a solution to equation 2. So I got to make sure that 2 -1 is not a solution. So let's make sure that 2 -1 is not. So -1 equals oh, yeah, I made an equation for it. That's bad. Okay, so I can't use 2 -1. Got it. So I got to pick another value. Oh, sorry. Okay, sorry. So that didn't work because I used that point. So let's pick another point. Yes, we can still use this technique. This is a good technique. I just got to pick points better. Sorry, Mac. So let's not pick 2 -1. Let's pick 3. Okay. 3, 0. Will be hard. Will be challenging. It's okay. We'll pick a point, even though it's not going to be. Let's pick 3, 1. All right, I think so. Let's do 3, 1. So we get 5 minus 1, 5 minus 3, which is 4. That's a slope of, well, let's see. No, that's a slope of 2 also. Let's do 3, 0. Let's do what our intuition said. So you get 5 minus 0, 5 minus 3, which is 5 over 2, which is my slope going through the point 5, 5. So we have 5 equals 5 halves times 5 plus b. Oh, this is going to be ugly. Over 2 plus b minus 25 over 2 minus 25 over 2. That's going to be positive 10 over 2. So we get negative 15 over 2 equals my b. So my equation is y equals 5 halves x minus 15 halves. Okay, now let's make sure it doesn't go through 2, negative 1. 2, negative 1, we have negative 1 equals 5 halves times 2 minus 15 halves. That's 5 minus 15 halves, which definitely doesn't equal 1, because that is going to be 10 halves minus 15 halves is 5, negative 5 halves. Does not equal negative 1. So we know this equation does not go through it, and this is my other equation. So this equation does go through. This is write a system in which 2, negative 1 is the solution of equation 1. Oh, hello. Yeah, my bad. Equation 2. 2, negative 1. All right. I didn't find one that was an equation of 2, negative 1. That's why I did the other one. Hello. That would have been my equation number 1 and my other one. Oh, Mr. Mac. You're almost done with this. This was the last problem. We're going to redo it. Redo it. No, let's not clear the ink. Let's just go back to, is 2, negative 1 a solution to this one? So 2 times 2 plus 3 times negative 1. 4 minus 3. No. All right, so that wasn't a solution. So this is going to be system which is a solution. So this is equation 2. 2. I should have used 2, negative 1 like I did before. Slope is 2, I remember. I'm sorry. I'm sorry. I had it before. I had it, and I had made sure. I'd even checked my work, and it did work, which was good. And of course it did, because I used the points. Sorry, 5 minus negative 1 over 5 minus 2, which is 6 over 3, which is 2. We plug in the point, doesn't matter which point. Well, we'll plug in negative 1 equals 2 times 2 plus b. Negative 1 equals 4 plus b. Minus 4, negative 5 equals b. Did I do that right? Slow it down, Mr. Mac. Yep, that's good. So we get the equation y equals 2x minus 5 is equation 1. Equation 1, equation 2, y equals 2x minus 5. Oh, look at that. They came up with the same one. They did the same technique. That's why. And x plus y equals 10. It's okay. That's any other one. Good. Sorry. That was a little confusing at the end. My bad. Good luck. Keep practicing.